Yeah, hello guys. Good, good morning. It's still morning. So I had some things I had to sort at work and I left my screen like this. I most likely might not remember some of the things we've done, but yeah, to an extent, I know that what we're doing here was kind of like um based off inversion of control. So I can on you guys can understand like at least what inversion of control means. So this is we inverting the control. We're switching the control from this undercar. We're switching the control from this undercar to to our main file. So we can easily read through this code and know that yes, the undercar has a dependency called engine, and we can easily switch between the engines from here, and it makes the code much more readable, right? And it reduces coupling. Yeah, it reduces coupling in your software. Anyways, another thing you would notice is it makes your code much more testable, right? It makes your code much more testable. That means you can test your undercar. You can test your undercar and just mock your own version of engine. So let's say I'm calling the engine Caesar's engine or that's mine's engine, right? Because this is the that's mine class, by the way. Yeah, that's my engine or something, right? You can test how the engine is going to behave. So let's say we have an engine called that's mine engine, that's my engine dot dot. So let's say we have an engine called that's my engine that also implements that's my engine. Yeah, that implements engine. You see how this is going to be interesting. So let's say we set in the type to something to that's mine. Seriously. Yeah, we set in the type to that's mine. And we want this to maybe perform an action before start. Let's say before start, we want to turn on the lights or something. Turn on, turning on and green lights. Turning on and green lights. Um, why is my key falling out? I don't know. For some reasons, my end key is falling out. Yeah. Okay, let's go back. So turning on engine lights, ensuring um the gear system or the gear system is in fact, or something. I don't know what to call this, but yeah, ensuring the gear system is in fact good. Then come here and before starts and print starting with engine. Seriously, start saying the engine. Okay, now we have an action that we want to work before we actually start like the engine or something. I don't know. But yes, we can easily now test this that's my engine on its own, right? We don't this can be kind of like a mock class. Let's switch this to mock. This can be kind of like a mock class that can be used during tests. So let's say we want to test like the behavior of how an instance like this will work. We can easily just test this against our Honda car very, very easily, right? Yeah, I know I most likely have been speaking in parables. I most likely have not been 100% like straightforward because of the fact that I'm using a car and 90% of the time, right, you will not be building a system that I'm sorry, I don't know where I got my stats from, but I feel like that's you not 90% of the time you not be using a CAD system, right? You not be writing a code that involves like engine, to be honest. So one thing I love to do is when I explain with analogy, I explain with something that can be related to that at least most people would actually write code or would write most people would write code about, right? And that is a user system. Let's open CMD. Let's see the into documents and let's create. That's great. User system. I don't know if I should push all this to if you guys would read this code. But yeah, let's create like a user system file or a folder rather, or that folder. See the user system that, and let's open. Yeah, I got a bit distracted, so I am back now. So we launched the user system.dat file, and the very first thing I like to do, let's increase the size of this. I don't know if this is better, but yeah, the very first thing I like to do is just clear this bin, and let's use delete and create a main folder, a main file rather, main of that, and then void main should be yeah, yeah, the IntelliSense did its job, right? So let's build like a user system and try to understand the the scenario. I don't know if I deleted something. Oh, I deleted the readme first time. So what I was trying to do. Yeah. So let's try to build a user system, just like you would see in a real world scenario, at least most of the time, right? As a Flutter or that developer, you're most likely building for your user. And somewhere here, I have this folder structure and file structure that we are going to be using, or through we're going to be using to build our simple like dependency injector and service location or locator application. So this is just to help me keep track of what I really want to do. Um, okay, I just realized I did not add the service locator to the key component in which it is part of the key component, so service locator, service this locator. Anyways, this is whimsical. You can use it to draw whatever structure you want to draw, or maybe you want to design a system. This is what I use, and they've been very much impressive. They are not sponsoring this video, by the way. This is just me speaking to as you can see, right, speaking to what I've been using over time. Anyways, back to this. We have the lead, we have models, we have services, we have repository, we have main, we have the injector, we have like a service locator. So let's start by defining the folders on this project. Let's start with defining the folders on this project. Yeah. Okay. So the very I'm on the wrong file. I'm on the wrong folder. It should be this. So we have this. We have models. We have services, and then we have repositories. I hope I'm not wrong. Repositories, repositories, and yeah, back to this. Yeah, these are the folders. Then we have injector.dat, injector.dat, injector.dat. injector, injector dot that. Then we have service locator, service locator dot that. Service locator dot that. Yeah. The models they have like they have a user, right? Let's confirm. Yeah, the models should just contain a user model. So you have dot just like your normal like model. User dot that. You have user service and you have user repository. Let's go back to this. That should be on the services. User service. User service dot dart. So you have user service dot dart, and then you have user repository. User repository dot dart. Yeah. What else? What else? I think we can start with this. We can start with this. So the first thing is defining the user model. What are the attributes? The attributes are ID and name. Yeah. But what are the editor types? Right, that's the question. What are the data type? So string class user capital letter user final string ID final string name. And we create a constructor called user constructor and be constants user, and let's make them name constructor required is is.id required swiftly. My keys are falling off. I think I made a mistake by, or probably I would just get like a glue or something. You required this dot name, required this dot name, and finally we have this. So we have our user model, and the next thing we want to have is like the repository, and then the user service that the repository gets injected into. So you understand. So let's create the repository. We can decide to have like an abstract class. Let's have an abstract class repository that acts as more like, do we really need an abstract class for a repository? We can have it for a user repository. So just in case, we have multiple users, let's say we have like an admin user, you have like uh maybe something else. You have multiple roles for different users, right? So we can have a user repository instead, because having a generic repository like abstract class doesn't seem feasible, because repository might not be specific to like just user, right? We can have a car repository. So we need to have like an abstract class that where we can define like general or common variables and common functions. Let's rename this. Here is the rename. So we rename to user repository, just in case we want to have other repositories like cars and we are not user repository. We have that already. Okay. Yeah, since we have user repository, let's just get rid of this. And then we can create like an admin class abstract class user repository. User repository. Yeah. So we have an abstract class user repository. What are the common things in like a user repository? In like a user, maybe gets user of something, future, future gets user, future get user. What do we need to get a user? We need the ID. String ID. Yeah. Then we can decide, oh, we what kind of user do we want to deal with? Let's deal with an admin user or something. Let's create a repository for an admin user. Admin user get that. And then it just implements user repository. Admin user implements user repository. Implement user repository. Yeah, since we are implementing, we need to override the get user. We need to override the get user function. And what will this do? This we can just give it like a delay that returns a random user, async awaits future dot delay. And just give it like a duration of. Should we give it 2 seconds? One. Let's give it. Let's give it to 1 second. Yeah, let's give it 1 second, and then we can return a user. So this should be returning a user. This should be returning a user. In the user, we can have something else called role final string role required via this this dot role, and yeah, we just return the user. Return user. Return user ID. The ID being parsed. The name Caesar. Um, role can be admin. We are not supposed we're supposed to use like an enum for this, but uh my key fell out again. We have a problem with n. So let me try to fix my key up. Okay. Uh yeah. So we need to update the streets. The next thing is what's the next? Right. We defined okay, we've now defined user service. The next thing is for us to inject the repository admin user repository, not admin user. This is weird. Admin user repository, and then admin user repository. So that way we can inject multiple types of repository depending on the case, depending on the yeah. Anyways, back to the user service. This is what the user service would look like. So we have a class user service that is dependent on a repository, on a user repository. User service that is dependent on a user repository. Naturally and normally, the way we define the repository is A. Yeah, we want this. You can define it this way and say, oh, admin user service, and say, hey, we want this to just be focused on the admin repository. Admin repository security equals to admin user repository, blah blah blah, and then just do this. And you fetch or get to the future future user, future user gets user. Okay, we need a string ID, and then we do this. Let's just do an arrow function. We are not doing too much. Admin repository don't get user, I guess. Why are you doing this to me? ID, right? Pass the ID, and this needs to be important. So you can see we have to add cookies, and wherever we're using the user service, right? Wherever we're using the user service, maybe somewhere in the injector, not necessarily in the injector. Let's say, for instance, we're doing it in the main. Let's say we're doing it in the main, right? And then we're using like the user service. We don't know what kind of repository is being used, right? So we need a way to control this repository outside of this user service. And we need a way to control, yeah, the repository outside of this user service. So we can easily switch between, whatever kind of repository we want to use. I'm already clocking 20 minutes again, but let me try to close up on this. So final admin repository equals to admin. So we just switch this and change it to user repository. Final user repository equals to this. And we create a constructor. This can be constant also. Admin user repository. Named or not named. It's just a variable. So repository. Let's see. Sorry. It's just a variable, so we might not. Oh, sorry, this is meant to be user service. I was so lost as to why I was getting error. And this is meant to be a repository. All right, so yeah, this is we just injecting, our repository into this. The next thing we want to do is in our injector, let's have a class called injector. This is just something that manages our dependency injection. This is most likely going to it's 30 minutes to be honest. All right. Let's just do it. So one thing I like to do is we can just like use a single thing for this. All right. So we have just one instance of the injector because we don't want to have to start like whenever I want to use the injector, we don't want to start creating an instance of um an injector every time. We can also use like static variables, but I feel like it's going to be a bit like excessive. I don't know. I don't know having for me, right? For me, I prefer to use like singleton over having static variables and classes. Though it still requires you having like something that is static anyways. But yeah, let's just open and create like a function that accesses the user service or that gets your user service so you can use it maybe somewhere else in your application. Um, admin user service. Weird. It is meant to be just user service because it's only the repository that would know if it's an admin or not. So yeah, user service, user service, gets user service, service, gets user service, and final user repository, user repository. Let's just say admin user repository equals to admin user repository and return user service. So this is just like the injector that helps us inject the dependencies for whatever services we're going to be using in this application. User repository. Oh, admin user repository. Yeah. And yep, yeah, I like to make like this like a single tick class so that we can easily just access this from like from whatever instance, and it uses the same instance over and over again, right? So it uses the same instance over and over. So we don't have to create new instances for our injector because it's totally worthless, right? Having to create a new instance. So we just want to reuse the same instance every time. So I'm going to make this class singleton, right? Which is just as simple as creating a factory constructor, injector, blah blah blah. And we want to return an instance that can be static final injector singleton singleton equals to we need we need um kind of like an internal class or an internal like constructor that we can use. And say not public or let's use internal. Yeah, let's make it private. That we can use and just call this. Yeah, and just call this and set this to injector.internal. And we return singleton here. Singleton. And yeah, let's just have like this get that we can use to get the instance. Static injector gets instance. All this does is it returns singleton also. So if you create a new instance of this object, it still uses the same instance, or you can just call the instance directly from this. So that's just what I am using like this whole singleton structure for. Okay, what else? So let's try to use this in our main. This is we're trying to fetch user, right? So let's try to use this in our main thing. The first thing is to define user service. User service. We define user service, which is injector dot instance dot get user service. Get user service. And final user. My end key for tail again. Final user equals to awaits. Let's make it a send. Awaits user service dot get user and person and ID, which can be 1 2 3, and person and ID can be 1 2 3, and just let's print fetch user. Fetched user. Fetched user. User.name. Yeah, my key fell off, so let's run this. So as you can see, right, automatically you can see how it's easy for us to, inject the dependencies directly from this injector. So you can have an injector class that manages all injection. We would not be able to talk about service locator in this, video because it's already way too long. This is 30 minutes already. Yeah. So in the next video, I'll just talk about service locator and just wrap the whole tutorial up. Oh, right. I should have just made this kind of like a crash course or something on dependency injector and service locator. Yeah, thank you very much for watching. See you in the next video.